Dear students, here is the next video as I promised that it will be based on IUPAC nomenclature for alcohols, phenols and ethers. The chapter belongs to class 12th chemistry. So let's discuss NCERT examples as well as in-text and exercise questions to understand how IUPAC names are written for these organic compounds. So this is a table from your NCERT only. I am purposely taking the examples from NCERT. I am restricting it to NCERT so that you understand the basic nicely, and then you can apply it. You can practice as many examples as you want. That will give you more clarity. So this is the minimum that we have to do. So I have taken maximum examples from NCERT from this chapter. This is a table. In this table you will come across alcohols with their common names as well as IUPAC names. Now students have this query that should we remember common names? So my answer would be yes. Those common names which are given in NCERT, at least those you must know because they can be used as it is in questions. So you should understand what is isopropyl alcohol. You should know what is glycerol if it is given in NCERT. So you should remember the common names also and apply the rules to write the IUPAC names. Now the first one is simple. This is methanol. I am talking about IUPAC names. Common names are simple methyl alcohol, you call it. Then you have this with 3 carbons and OH on the first carbon. So this becomes propane 1-ol. Here also 3 carbons alcohol and OH is on the second carbon. So these two are isomers. So you call them propane 1-ol and propane 2-ol here. Right? Simple. Now if it is propane 1-ol, if it is a straight chain and on the first carbon you have OH, then you call it N-propyl, that is normal, N-propyl. But if you have this kind of arrangement where again 3 carbons but OH is on the second carbon, now you can see that there are 2 methyl groups on the same carbon, this methyl and this methyl. So whenever you have 2 methyls on the same carbon, you use the prefix iso in common naming. So 3 carbons, so isopropyl. This is isopropyl alcohol and the IUPAC name is propane 2-ol. Next, again you have isomers, 4 carbons each. You can see the OH is on the first carbon here. So this is butane 1-ol. And here you have OH on the second carbon. So this is butane 2-ol. Now the first one is called N-butyl alcohol, like N-propyl. And the second one is secondary butyl. Let us understand this also. Why they are not calling it isobutyl? Because for iso, the condition is that 2 methyls should be on same carbon. Here 2 methyl groups are not on the same carbon. So I cannot call it iso. But the carbon which is attached to OH is directly attached to 2 more carbons. So definitely I can call it secondary. Now the question arises, can we call this secondary propyl? Yes, we can. This is secondary propyl alcohol, isopropyl alcohol. But here this is secondary but not iso. I hope you have understood the difference. Next is 4 carbons again. But now you have branching here. Again isomer. This is also isomer. These 4 are isomers. But the difference is here you have a straight chain. Here also you have a straight chain, you can say. But the placement of OH is different. Here in these 2 cases you do not have a straight chain. There is branching. So you choose the longest carbon chain. This is propane 1-ol and on the second carbon you have a methyl. So it becomes 2-methyl propane 1-ol. Here you have 3 carbons in a straight chain. On the second carbon you have OH as well as CH3. So it becomes 2-methyl propane 2-ol. Now see the interesting common names of these 2 compounds. This is isobutyl. Why isobutyl? 2 methyls are on the same carbon here and total 4 carbons. So butyl and iso I can use. And here in the next one you have 3 methyl groups on the same carbon. So it becomes tertiary butyl. tertiary. You can call it neo also. Neo means 3-methyl on the same carbon. Tertiary because this carbon which is attached to OH is attached to 3 more carbons directly. So this is also called tertiary butyl. IUPAC names we have already understood for these compounds. Now you have diol, 2 carbons, ethane, and on both the carbons you have OH, so ethane 1,2-diol. In IUPAC naming everything is important. Dash, the hyphen, and between 2 numbers, comma, after the number again you have hyphen. All this comes in the rules of IUPAC, so you should know them. Okay, and here you have propane 1,2,3-triol, ethane 1,2-diol, propane 1,2,3-triol, and their common names are, this is ethylene glycol and this is called glycerol. So these are very important common names we must remember. These also I have taken from the NCERT. This is generally when students look at it, they'll quickly say phenol. Be careful, this is not phenol. This is phenol. This is not having the double bonds in the cyclic structure. So we call it cyclohexane. Cyclohexane with OH is cyclohexanol. That's the name. Cyclohexanol. It has to be a single word. Next, this one. You have 5 carbons ring. So cyclopentane clearly. There is OH, so cyclopentanol. And OH has more priority. This is the functional group. So this carbon which is having OH is numbered 1. So this carbon will be numbered 2 where you have methyl. So the name becomes 2-methyl. On the second carbon you have methyl. So this is 2-methyl. And then cyclopentanol. Right. Okay. I told you 1 and 2. Now it will be more clear if I write. I hope. This is 2-methyl. On the second carbon you have methyl. If you move like this, then this is also second carbon. So the rule in the cyclic compounds naming is that you go clockwise or anti-clockwise anyhow, but you should reach the other carbon which has a substituent by giving it the lowest possible number. So I will not come from here and give it number 5. I'll go from here. So this becomes 2-methyl cyclopentane cyclopentanol. I don't need to write cyclopentane 1-ol because it is understood that this is 1. That's why the number 2 is given to this one. Next, these 3 are interesting isomers. They have very different common names. This is catechol. IUPAC name is simple: benzene 1,2-diol, benzene 1,3-diol, benzene 1,4-diol. Common names you have to remember. This is catechol, this is resorcinol, and this is called hydroquinone or quinol. This is quinol, benzene 1,4-diol. Then you have phenol. Then we have phenol, and there is 1 carbon with a methyl substituent on it. Now if you have a methyl substituent here, then this is called, now I'll go like this, 1, 2. As I told you, you have to give the lowest possible number to the next carbon which has a substituent. So I'll go anti-clockwise. So it becomes 2-methyl phenol. Common name, interesting, orthocresol. Here 1,3, so metacresol. Here 1,4, so paracresol. And IUPAC names, this is clearly 3-methyl phenol, this is 4-methyl phenol. Do them by writing so that it becomes more clear to you. Then you have next table which belongs to ethers. Ethers are the compounds ROR. Generally we write them like this: ROR dash. R dash and R may be same, they may be different. So these are called alkoxy alkanes. If I have CH3O, CH3, both R groups are same, then we don't have to think methoxymethane. But if I have one R group smaller and the other R group bigger than that, so the bigger one is always alkane and smaller one is always alkoxy. So it becomes methoxy alkane. This is the name. So let us see the examples here now. This I already told you. Common name is dimethyl ether because both sides you have methyl, so it becomes dimethyl. Same way, if you have ethyl on both the sides, it becomes diethyl ether. And the IUPAC name would be ethoxyethane. Here you have 3 carbons in the bigger R group, so this is propane. And on the first carbon, you have OCH3, so it becomes 1-methoxypropane. Common naming, methyl, this alkyl group, on the other side N-propyl, and then put the word ether. This is how you write the common names for ethers. Then you have the next C6H5OCH3. So this is benzene, C6H5, phenyl attached to OCH3. Methoxybenzene, and commonly it is called anisole, which is used in IUPAC also. Or you can call it methyl phenyl ether. Its common name. Anisole is used in common as well as IUPAC naming for this particular compound. Here you have 6 and 7 carbons in a straight chain, so it is clearly heptane. And on the first carbon you have this. Now 7 carbons this side and 6 carbons this side, so obviously this is bigger, this is alkane, and this part becomes alkoxy. I cannot call it benzoxy. The term used here is phenoxy because C6H5O is a substituent. So whenever we use C6H5 in the form of a substituent, we use phenyl. Because of oxygen, it becomes phenoxy. So the IUPAC name is phenoxy, 1-phenoxy. It is on the first carbon, and heptane, 1-phenoxyheptane is the name. Next one. This one, mostly whenever I ask, students always give wrong answer because they say that 2 carbons and you have a methyl substituent and you have a methoxy substituent. Now what is wrong in this? The wrong in this is you have to see the alkane part first, the bigger one. How long is it? It's 3 carbons. 1, 2, 3. And on the middle one you have OCH3. Then I draw it like this in the class and they always say, yes, 2-methoxypropane. Then why this is not 2-methoxypropane? This is also 2-methoxypropane. They generally say this is one substituent methyl, this is the other, so it becomes methoxy methyl ethane. No, that is totally wrong. This is the correct name, 2-methoxypropane. Then you have the next example. This one, 1, 2, 3, 4, 5 carbons. And this is phenoxy. Now, should I call it phenoxy or I take this as a substituent because there are only 5 carbons this side? How to decide that? As I told you in the beginning, that you have to see R, O, R dash. The bigger R group is always alkane and the smaller is alkoxy. So here you have 5 carbons this side and 6 carbons this side. So this is clearly bigger. I'll take benzene as the main compound. And on benzene you have this as a substituent. So this part becomes alkoxy. Now we have to name this alkoxy part, right? It is 1, 2, 3, 4. Butyl, right? 4 carbons should be butyl, and on the third carbon you have methyl. So 3-methyl butyl, but I have oxygen also. So it becomes butoxy. 3-methyl butoxy. This is the substituent on benzene. That's the name. If you are getting confused, let me explain it again. I told you that on both the sides of oxygen you have different R groups. So the bigger R group is the one which has more number of carbons is taken as alkane and the smaller as alkoxy. So you have 6 carbons here and 5 here. So this is the main compound benzene and this is the substituent. 1, 2, 3, 4. 3-methyl butoxy benzene is the name. Next one, you have 2 carbons in the middle and 2 methoxy groups on the carbons, both the carbons. So it becomes 1,2 dimethoxy ethane. This is ethane and it has 1 and 2 carbon. On both of them it has methoxy. So 1,2 dimethoxy ethane. And the last one, which is a cyclic one. 6 carbons, so it is clearly cyclohexane. In cyclohexane, you have 2 methyl substituents and 1 ethoxy. So you will write them alphabetically. So ethoxy will come first. In the IUPAC naming alphabetical order of substituents, you will not see the D of di. You will see the M of methyl. So E will come first, right? So it becomes 1, 2. 2 ethoxy, 1, 1 dimethyl, cyclohexane is the name. Now one question arises that why we can't give number 1 to this if we are writing ethoxy first and 2 here. That will be against the lowest sum rule. In the name then it will be 1 ethoxy, 1 here and 2, 2 here. So it becomes 1 plus 2 plus 2, 5. Lowest sum rule is being violated. So you have to give the lower number to this, which is coming twice, and the bigger number to this. So this is the IUPAC name. This is the solved example from your book NCERT. Give IUPAC names of the following compounds. You have to see it carefully. Simple rules. OH is the main functional group. This is the secondary functional group. Halogens, nitro, alkoxy, they do not come in the main functional group, so they are always secondary. Now the carbon having this OH is number 1. So 1, 2, 3, 4, 5 carbons I can see. It becomes pentane 1-ol. On the second carbon, on the third carbon you have CH3. On the fourth carbon you have Cl. So you write alphabetically. You will write 4-chloro, 2, 3 dimethyl pentane 1-ol. See, when I write pentane 1-ol, I have dropped the E, which was here a pentane. This is also in the rule. It cannot be pentaneol. It is pentanol. So I have removed that, right? 5 carbons here. Second part, this one. 3 carbons here, 2 carbons here. It's an ether, right? So this is propane, and on the second carbon you have ethoxy. So this is 2-ethoxy propane. Simple. Write them with me, or when you are looking at the video again, the purpose of making the video is this only, that once when you are looking at it for the first time, try to write with me. If you are not able to match up, if you want to go slow in the beginning, then stop the video anywhere, focus just on one example, understand, and then do it. So if you do all these examples, you'll be perfect in IUPAC. Now this is clearly phenol, and there are 2 methyls. So this has to be number 1 carbon. Now you go clockwise, anti-clockwise, anyhow you are going to get the same numbers, 2, 3, 4, 5, 6. So the name is 2,6 dimethyl phenol, single word, right? Last one in this example. This is cyclohexane. Be very careful. Students generally write benzene, phenyl. Don't do that. See carefully. There are no double bonds inside, so it has to be cyclohexane. And you have nitro group and you have alkoxy group, which is ethoxy group. They both do not come under the main functional groups. They are always secondary. So go alphabetically. Ethoxy will come first. Nitro will come second. So 1 and 2. So it is 1 ethoxy, 2 nitro The word will go on like this. Single cyclohexane. 1-ethoxy 2-nitrocyclohexane is the name. Let's try this IUPAC names. I can see OH here. So this carbon will definitely be given number 1. Now you start going in different directions so that you get the lowest possible number for the substituents bearing carbon, and you get the longest carbon chain. So 1, 2, 3, 4, 5. If I take this, it becomes pentane 1-ol again. I can see this chloromethyl here as a substituent. I can see this isopropyl as a substituent. So name would be, for this, it's going to be 2, 3. There are 2 substituents, chloromethyl isopropyl, right? So if you write this chloromethyl and isopropyl, then alphabetically 1, 2, 3, 4, 5. 3 chloromethyl, 2 isopropyl, pentane 1-ol. Okay. Here the next one. I hope this is clear. Next is, let's write for the second one. OH 1, 2, 3, another OH 4, 5, 6. So this is hexane 1-ol. On the second carbon there is methyl, on the fifth carbon there is methyl. Simple. 2, 5 dimethyl hexane. I'm putting E now because there are 2 OH groups here. So hexane, clearly 6 carbons, dash 1, 3 dash diol. There are 2 OH groups, so this is the name. Third one is simple. Cyclohexane. And you have OH here, so this is having more priority according to priority series. So 1, 2, 3. The name is 3 bromo cyclohexanol. That's the name of the compound. Next, fourth, 1, 2, 3. If I go from this side, 1, 2, 3, 4. Now the problem is that the functional group is OH and there is a double bond. So clearly OH is the main functional group. I'll go by the rule that main functional group bearing carbon should get the lowest possible number. So I'll come from this side. Why? Because this is getting the lower number 3. Here it is getting 4, so we'll avoid that. And the other thing is, if I'm coming from this side, then automatically the carbons having the double bond are also getting the lower number. So the perfect choice is 1, 2, 3, 4, 5, 6. This is hex 1-ene 3-ol. Hex 1-ene 3-ol. I have not put E and E here because OL has come. There is no diol or something. That's why. The last one is 1, 2, 3, 4. On the first carbon you have OH. Between second, third there is a double bond. On second there is bromo. On third there is methyl. So longest carbon chain 4 carbons. It is but-2-ene 1-ol. Apart from that, 2 more substituents here. So how do I write the name? I'll write bromo will come first. 2 bromo, 3 methyl butane, not butane, this is butene, so let us just write it again. Yeah, we have to be careful about this is butene, right? So that was 2 bromo 3 methyl, alphabetically I am writing but 2 in 1 all, that's the name. Okay, let's go to the next one. Now this is simple. Name is already given, you just have to draw the structure. So you always have to see the last part, that is the parent compound, and then put the substituents which are given in the beginning. Butane 2 all, 1 2 3 4, second carbon OH, this is my butane 2 all, and on the second carbon again you have methyl, so put methyl here. Then complete the 4 bonds of each carbon by putting the hydrogens. This is the structure. Second, 1 phenyl propane 2 all, parent compound, 1 2 3, propane 2 all. Phenyl means on the first carbon there is C6H5. Complete the remaining bonds by putting hydrogens. That's the compound. This is easier. If IUPAC name is given, you know the rules by heart, then there are hardly any chances that you will go wrong in drawing the structure if name is given. So this is comparatively easier. This is hexane 135 triol. 1 2 3 4 5 6, because it is hexane. On the first carbon OH, you can count from left or right any side, but then follow that throughout the name. So I am counting this 1 2 3 4 5 6, right? On third there is OH, on the fifth there is OH, triol ho gaya. Now 3 5 have methyl also on them, so 3 पे एक methyl and 5 पे भी एक methyl. Now complete the remaining bonds. CH2, this is CH2, this already has 1 2 3 4, this has CH2 already 4, this has CH3, done. Phenol is the parent compound. Phenol. Second carbon ethyl, third carbon ethyl, done. 2 3 diethyl phenol. Last, 1 ethoxy propane, CH3 CH2 CH2 propane. On the first carbon OC2H5, that is ethoxy, done. Next, 2 ethoxy 3 methyl pentane, 1 2 3 4 5, 2 ethoxy, this is ethoxy, 3 पे methyl and 5 carbons, complete the 4 bonds, done. Next है बेटा cyclohexyl methanol. Okay, methanol is CH3OH, but it has cyclohexyl also, so I have to make it CH2 and put cyclohexyl here. That's the compound, cyclohexyl methanol. Simple, right? Next is pentane 3 all. So 1 2 3 4 5, on the third carbon OH, and 3 cyclohexyl on the third carbon, cyclohexyl also, right? And then complete the bonds again. This already has 4, this has only 2, so I am putting 2 more. It has only 1, I am putting 3 more. That's how you complete the structure. Next is cyclopentane 3 in 1 all, pentane 3 in 1 all, but there is cyclo also, so I just cannot take the pentane 3 in 1 all part, I'll go wrong. Cyclopentane, 5 carbons, cyclic structure, and then number from anywhere. 1 all, you put OH anywhere and take that as carbon 1, number 1. So 3 in, that means between third and fourth carbon you have the double bond, so put the double bond here. This is the structure. Cyclopentane, double bond, and then OH here. And the last is 4-chloro-3-ethyl butane 1-ol. 1, 2, 3, 4. Butane 1-ol. And then on the fourth carbon there is chloro. On the third carbon there is ethyl. Ethyl, right. So and if you go by IUPAC rules now, if I give you this compound and ask you the name, then you will go like this, because this becomes the longest carbon chain. We have done one example like this. This is the longest carbon chain, so it may be confusing at times. This is chloromethyl. We have done one such example. So the name becomes 1, 2, 3, 4, 5. Right, this is pentane 1-ol, and on the third carbon you have chloromethyl. So the first thing is choose the longest carbon chain. If they give you this, then this is going to be the structure. It cannot be anything else, right? But if they give you this, then write the name as we have written earlier also for chloromethyl. Okay, this is the question from exercise, which has many parts. So let us do it quickly. IUPAC names we have to write. So I'll choose the longest carbon chain. 1, 2, 3, 4, 5. I can see 1, 2, 3 methyl substituents and 1 OH functional group. So this is having 5 carbons. So this becomes pentane 3-ol. And on the second carbon you have 2 methyl substituents. On the fourth carbon you have 1. So it becomes 2, 2, 4 trimethyl pentane 1-ol. That's the name. Next one is 1, 2, 3, 4, 5, 6, 7. There are 7 carbons. So this is clearly heptane with 2 OH groups on second and fourth. Heptane 2,4-diol. And on the fifth carbon we have ethyl. So it becomes 5-ethyl. This ethyl substituent. Heptane 2,4-diol. Next is simple 4 carbons, and on the second and third from any side you have OH, so diol. So this is butane 2,3-diol. Next propane, and you have 3 OH groups. Yeah, this is, if you remember the common name we have done in the table, try to recollect. IUPAC name I am telling you, it is propane 1, 2, 3, E will come here, triol. Then you have phenol, and on the second carbon there is methyl. So this is 2-methyl phenol. This is 1, 2, 3, 4. This one 4-methyl phenol. Next one, the seventh part, phenol again. Now 1, if I go clockwise, I'll give 2, 3, 4, 5 numbers. So substituents are coming at 2 and 5. But if I come anti-clockwise, so 1, 2, 3, 4, 5, 6. Substituent bearing carbons will get the number 3 and 6. So I will go from, I'll follow this because the lowest number we are getting this way. So 1, 2, 3, 4, 5. The name is 2,5-dimethyl phenol. And the last one, again phenol substituent. Go clockwise or anti-clockwise, you will get the same numbers for methyl carbons. 1, the carbons bearing methyl as a substituent. 1, 2, 3, 4, 5, 6. So it becomes 2,6-dimethyl phenol. 6 dimethyl phenol. Next, ethers. You have one carbon on this side and 4 on the right side, so clearly this is the alkane part. 3 carbons in the straight chain, and on the first, second, third, on the second carbon you have methyl. On the first carbon you have methoxy, on the second carbon you have methyl. So alphabetically methoxy comes first, O comes first. 1 methoxy, 2 methyl propane. Next part, you have 6 carbons here and 2 here, so this is the alkoxy part, smaller one, and this is benzene. So this is ethoxy benzene. Next, 7 carbons here in a straight chain, N is written, N normal straight chain, and 6 here. So heptane is the main compound and this is the substituent. So this is 1 phenoxy heptane. And now the last part of this question, I guess, 12th part, easy. 1 2 3 4 butane I can see, and this is the smaller one, ethoxy. So 1 2 3 4, 2 ethoxy butane is the name. So that's the end of this presentation. I have taken maximum examples, as many as I could take from NCERT to help you. I hope you will practice them nicely, and the next presentation I'll try to make from organic only, maybe the reasoning questions of this chapter first, or the chemical distinction test for organic compounds, because that always confuses students. So I hope the presentation is going to help you. Thank you very much.